So Trellis is our leaf-spine fabric. It's open source software, so it's open source based. It uses a lot of open source components, including as part of the reference.
I can see you on video. There you go.
Sorry. The podium is taller than me, unfortunately. Okay, so Trellis is based on open source software. It's also using white box switches, so you'll see that a lot of our implementation is based on OCP certified hardware. And it's SDN based. I have to figure out where I can clip in the middle.
How do I get rid of this timer?
Minimize things on it.
I can't see it. Can you see it? I can't see what I'm pointing at. Okay.
Maybe get out of presentation mode.
Okay.
Okay. Okay, so our third attempt at this. It's SDN based, so what you'll see as part of the solution and the control is using ONF that Thomas has just gone through.
You keep going.
So here's our leaf-spine fabric. What we have in terms of testing is we've actually deployed it with an ONF cluster. So you'll see that there's HA components to this. The fabric supports access and trunk VLANs. So you can specify tagged or untagged traffic going from your host into the fabric. And then as it egresses the fabric, your traffic is tagged appropriately. Within the context of each, actually, I'll touch on this real quick. So within the context of each rack, what you'll have is your traffic is L2 bridged, right? So if your traffic goes within the context of each of the rack, it'll be bridged. If you go into across the fabric, what you'll see is your traffic is actually ECMP hashed. And so it'll pick the appropriate spine and then head down to the next leaf. What it uses is MPLS segment routing. So it uses labels in order to get your traffic to the appropriate leaf. We've also added IPv4, IPv6 multicast support, so you can have support for IPTV use cases, for example, DHCP, L3 relay support, BGP support. So within the fabric, it's actually treated as like one big router. So as you look at the fabric and from a peering standpoint, it'll appear as one big router. Dual homing. We've added support for dual homing, so you can have dual TORs, and then you can have hosts that are connected within a rack to the TORs and then up into the switch. We're looking at supporting access so that you can have access devices that connect to two leaves. We've added pseudo wire support as well as Q&Q termination. So one of the use cases we're recently looking at for ArcCord is what we call a fast path, right? So not having a VSG where your Q&Q termination would occur. What we'll do is we'll actually strip off the double tag VLANs and then send it where it needs to go. Towards production readiness, this is a term that you've heard consistently throughout our presentations. This is what we're pushing towards as we look at our different projects and deployments. So what you'll see here is, as part of the Trellis ecosystem, we're working with a bunch of partners, the main one being Comcast in order for us to get to deployment. Right, so we're working very closely with them in conjunction with a bunch of different partners. You've got Nokia, you've got Broadcom, EdgeCore. So one of the things that we're working a lot on is, Thomas touched on this, right? We're adding functionality in terms of scale. We're hardening the platforms in terms of HA, adding ISSU to make sure that from a deployment standpoint, you can upgrade your deployments. And so there's a lot of functionality that's being worked on to address some of this. Part of this is within the last 4 months, we've looked at 7 releases in order to be able to make progress on enabling Comcast to do their deployment. There are daily scrums that the team meets together with in order to move this project forward. There's work going on with Broadcom. So as part of our reference implementation, for example, we're using Broadcom-based hardware using OFDPA pipeline. So a lot of work is working to make sure that we have the functionality in place to enable the features that are needed. Nokia has been working with Comcast and the team to deliver some of the IPv6 functionality that was needed for the deployments. EdgeCore, we've been using EdgeCore boxes, so working to make sure that functionality is in place. And of course, we have pods that are being put together in Harmonic and hosted by Harmonic and Flex. So there has been a lot of traction within the last 3 or 4 months, right, as we've worked very closely with Comcast to enable this deployment. So what you'll see is from a support standpoint, lots of new functionality. There are daily scrums to work through issues, to debug, and make sure that issues are identified. Those are getting addressed. New functionality, as Thomas had noted earlier. So other teams that we're working with closely, Broadcom, Nokia, Harmonic. And then as new features are being developed, you'll see that we've added pseudo-wire support, multicast, dual homing, a lot of functionality in terms of HA stabilization, ISSU to make sure that we can upgrade in the field. And then ONF stability. So as we look at the requirements for route support, as we look at the scaling support, there's a lot of work going on in Atomics in our HA library in order to enable this functionality. So one of the things you'll see is there have been 9 releases of Atomics in the past 4 months to enable this. And of course, tooling. We've created a tool called T3 that would allow you to actually, based upon the header specified, trace a packet flow through the system. So this would enable us to be able to better debug the system. And of course, from a QA standpoint, there's a lot of work to make sure that new test cases, new automated test cases are put in place so that we can better make sure of the stability of the platform as it gets deployed. Trellis and P4. As Brian's been mentioned in his talk, there's a lot of work going on at ONF around P4 as we look at that next generation of interfaces and being able to support that next generation SDN. So what you'll see here is that the way Trellis works is there's a set of applications that are hosted on ONOS. What we've been trying to do is we want to make sure that those are preserved. So if you look at the ONOS architecture, Thomas touched on this where we have a southbound. So today, as part of Trellis, we support a OpenFlow southbound that uses a DPA pipeline, right? This supports your Broadcom Qumran, Tomahawk, Trident. What we added recently in the past few months is P4 support. So we've added P4 as a stack to ONOS, the southbound, in order for us to be able to support P4-based devices. We've also recently added GNMI to be able to do ports configuration. So what that enables is we can preserve all the applications that provide segment routing, for example, and be able to then have a mixed fabric that supports both OpenFlow devices as well as P4 devices. So these devices now run programmable chips, including the Barefoot Tofino, Cavium X-Plant, and Mellanox boxes. So one of the things that you may be interested in seeing is we have a demo on the show floor booth 18, where we're going to be showcasing VNF offloading. So we're taking functionality that is part of MCORD, so the serving and packet gateway functionality, and we're taking that, defining it as part of a P4 program that we've also done within the context of building out a fabric, a P4 fabric, and that allows us to be able to do GTP tunnel NCAP decap. And so take a look at that because we're able to get better performance as we're offloading this functionality back into the hardware. So you'll see that as part of the demo. We've added a demo around in-band telemetry so that you can look at the telemetry that is associated with the packet flow through the system. So take some time, go and check out our demo. But what you'll see is this will enable us to have a P4 fabric. And so it'll fully allow us to support that migration path that Brian touched on, right? So if you have OpenFlow devices today, with this, you can fully migrate to a P4-based fabric. So Cord. Trellis supports our networking infrastructure. So if you look at a Cord pod, Trellis is the fabric for that. As part of Trellis, we have the underlay. So the functionality I've been talking about in terms of segment routing, all of that is provided in terms of the underlay. What we have then is a set of compute nodes that is in the Cord pod. And with these, the VNFs are actually connected using an overlay network using VXLAN tunneling. And then we're able to have unified control of both the underlay and the overlay. And so we have ONF deployed as part of the Cord with all the various applications deployed on top of it that would allow us to fully control this. And so what you see is functionality that we can provide, right? So your service composition is part of Cord, so it allows connectivity between your VNFs to support the service training, be able to support routing across the Cord pods, as well as bridging within the context of each rack, the dual homing functionality we had talked about. So as part of Cord 6.0, we're looking at plugging in, as part of our Cord, some of the dual homing capabilities that was introduced to the fabric. So as you look at all of this, you can see that we are taking Trellis and we're pushing towards deployment. These are all the partners that we've been working with, Comcast being a key partner to ensure that we can get this into deployment, as well as Broadcom, Nokia, and others. Any question? Please don't ask hard questions.
Question? Okay.
Hello, this is Yakup Alper Erdoğan from Türk Telekom. And you mentioned that you applied the CUPS architecture on the Mobile World Congress in Barcelona. And I'm wondering that you applied the CUPS architecture and you said that we've seen performance improvement. How did you calculate that? Did you compare with the legacy systems, or did you see compare between the legacy VNFs?
So we haven't gone that far. What we've been doing is we're using INT to calculate latency. So what we're trying to highlight is that as you're taking some of the VNF functionality that was previously in compute nodes and push it down to hardware, you're able to better realize it in terms of blind rate. And so what we're trying to show is there's lower jitter latency. So that's what we're trying to demonstrate as part of what we're doing with the demo. So what you'll see is, you'll see a couple of servers that we're going to deploy on a couple of the leads, and we're going to be pushing traffic over 100 gig link. And what we want to do on the other side is we'll take that traffic, right? We'll calculate, we'll add in INT headers at each of the transit nodes on the barefoot switches, because what we're deploying is essentially a leaf spine fabric with programmable ASICs. And so you have your barefoot as part of the leaf, and we're able to add P4 headers or INT headers as part of the transit nodes. On the other side, we'll have a netcope NIC that will take off the INT header and then push it up to a deep insight server, so Barefoot's deep insight server. So we'll be able to actually show the latency of that traffic as it goes through the fabric.
I see. Okay, thank you.
Okay. One more?
Yeah, I was very interested in a lot of oh, sorry, yeah, Steve Hilden from Telstra. Yeah, sorry. I was very interested in the set of features that you've developed more recently, because there are a lot of significant gaps that you're addressing there. I was just wondering, what version of Cord are they available in, and are you able to actually just make Trellis itself available outside of Cord?
So Trellis itself is, in terms of applications, are available as part of ONOS. And so that functionality is available there and is actually built into ONOS as a set of applications.
Yeah, so Trellis is released as part of the ONOS suite. Yeah. Anyone else? Thank you, Uyen.